Hello everyone. So let's talk about all paths from source to target. So you are given direct acyclic graph DAG of n nodes. Label from 0 to n minus 1. Find all possible paths from node 0 to node n minus 1 and return them in any order. So the idea is you are given a 2D array. So for node 0, the outgoing edges is 1 and 2, and node 1 is 3, node 2 is 3, and node 3 outgoing for node 3 is 0, which is empty bracket. And from what you actually need to do is you have to store for each path when the path when the path arrive to the last node in the graph, then you store the path to your result, and then you just keep doing this until there's nothing, then you'll just return result. So what I have is I have a list of this integer, and I'm going to call it result. And later on I do have a path. So I do have a path. So path is list of integer paths, right? So for my result, I could say new linked list just in case. I do need to remove last if there's anything happen. So path, I need to do the linked list as well. So I do need a helper function. So the helper function is you have to traverse every single node in the 2D graph, right? So I'm going to name traverse, and I do need a graph. I do need a integer path, and I do need to know where should I start. So which is my source? So I'm going to say traverse, okay, graph, and then path, and then start from 0 no matter what. And what you actually need to do is you need to know from node 0 how many paths can you go to, can outgoing to other nodes, which is 1 and 2, right? So you will say traverse graph, and path is still, and then v will be your new source point. And later on for the base case, you need to add. So when you visit for every single path, for every single node in the path, you need to add to the last element in the list of array. So for example, 0, right? You need to add to the last, which is, the first one, since the bracket is empty, the list is empty. Then when you traverse to 1, then you add to the last, and later on you know 3 is the last one, and you add 3. So that would be the super easy constraint. And later on, when your s is equal to graph.length minus 1. Why is minus 1? Because all possible paths from node 0 to node minus 1. So which means you already reached the last node in the graph. Then you need to add to the result. Okay, switches, sorry, the path. Then when you add to the result, right, there could be any other node possible to generate, right? So you need to say remove last from the path, and then you return. So here's it. So when I add 0, right, and then I traverse the node 1 and 2, and I traverse 1 first, and 1 will traverse 3, and later on I have another path which is 0, 2, right? So I need to remove last, which is 3, and you will go alternative way. So alternate ways is important, so you have to remove when you add to the result. And later on, if you cannot find any possible way to traverse, you need to remove the node that is non-important. So that would be the solution. And let's think, how do I get it? Okay, pass that at last. It should be a problem. Where is it? Path at last. So it should be a linked list. Sorry, it's not the list. It should be a linked list. And if this is happening, then I need to do this, and that would be, okay, sorry, I need to return. Sorry for making mistake, but this is how it is. And that will be the solution. All right, and let's talk about time and space complexity. So I'm going to copy my notes, time and space complexity, and this will be time and space. So 2 to n, what does 2 to n mean? 2 to n mean you either choose the path or you don't choose. Okay, let's 2 to n, right? How many node? N node. How many way for each node? 2 way. Okay, that would be 2 to n. And n square would be the will be the for loop stuff, because this is all of n, and traverse will generate another for loop. That would the maximum is all of n, all of n square. So that would be the time complexity, and space complexity as well. How many possible way? N 2 ways, right? For each node. Then how many node? N node. So 2 to n times n, because for every single node you could generate a path. So that would be 2 to n times n, and that would be the solution. And the question is pretty challenging for sure, and I hope you get it and try to code by your own. So I just made some mistake while I'm teaching. So just hope you the best, and peace.